Hi, it's Tim, and today I'll be showing you how to build a simple circuit in LTSpice and how to run a transient simulation on that circuit. Now I'm just going to quickly take you through Lab 5. To start off with, we're going to draft a new component, okay, and we're going to put down our new NAND gates. Okay, so I'm just going to place two of them here, okay, and now I'm going to draw a wire. Okay, and now we're going to put our switches in. So I'm going to draft a new component, and we're looking at that switch. So here we have two switches. We have our ideal and our bouncy switch. In this lab, we're just going to use our ideal switches here. Okay, so I'll place the voltage source up here. I'll just press G for ground. I'll ground here. I'm actually going to draft a net name. And we'll call this VCC. I'm going to place that up here, and also on our switches. Okay, and now the input to our switches is also going to be a voltage source. Just connect them with ground. And we'll wire them to the switches. And these will act as our control input signals. Hey, this is Editor Tim. As you can see, I'm making a mistake and putting this at high side, not low side, but I'll come back and correct this later. And we can see that outputting via an LED to ground. So I've made a little mistake here. This is actually low side, not high side. So I'll just delete these. Now you can see how this one here isn't connected. So I'm just going to delete that. And you know it's connected when you can see this little black. Okay, and to edit these resistor values, all we have to do is right click on them. For the LEDs, those will be 680 ohms each. And for the pull down resistors, they'll be 10 kilo ohms. Perfect, great. Now for our sources, these voltage sources, we can see if we click here advanced, they can actually be a lot of different values. So we can put them as pulse, sine waves, exponentials, but we're going to use these two down the bottom. So this PWL is called piecewise linear. So if I click that here, you can see at different timestamps, time 1, 2, and 3, we can actually input different voltages, okay? But for now, because we're actually doing quite a convoluted waveform, this will need a lot of inputs, we're actually just going to import a PWL file. And here I'm going to browse. This should be on your desktop. We'll have Lab 5, and I'm going to use, for Lab 1, we'll be putting in S and R. So I'll put this, and you can see here that we have the timestamps and the different voltage levels. And you can see how this one, it's at 1 nanosecond after 100 milliseconds that it changes. Again, this is a convention that we'll use throughout our labs. So at 0 and 100, at 0 volt, 101 nanosecond it changes. And that means instead of having something that goes up diagonally, it'll actually be a very fast transition, okay, because we want these to approximate square waves. Okay, and this will become clear as you go through the lab. Great, so we'll click OK here, and you can see that it's loaded in that file. We'll do the same here. Okay, and one more thing we need to set up, speaking of voltage sources, we'll add our DC value of 5 volts to here, so that means we'll have 5 volts in ground inputting to our circuit, okay? Okay, now to set up a simulation on Windows, there'll be a directive up here, but what we can do instead is we can draft a spice directed, and we can type .tran, okay? And we'll set this for 1 second, okay? So we know our files here go for around about 700 milliseconds, so 1 second should cover this. And the .tran is just telling the spice to run a transient analysis. Okay, so we'll place this here, and now we should be able to run it. So we'll just run here. We can see it's simulating. We see how it's stuck on this 700 millisecond mark. Okay, so just going to press pause here. Just going to pull up that simulation file, the window here. Great, and there's nothing on it because we don't have any traces, so we're just going to use this to plot these voltages. But what I'm going to do actually is I'm going to right click and I'm just going to label these nets. Okay. So we'll rerun this. We'll pause it again. And I'm going to plot these voltage. That's VS, this is VR, that's VQ, and that's VQ bar. And you can see they're all superimposed on each other. So what I'm going to do is I'm going to add 5 volts, well, let's say 6, to this VS to shift it up. Okay, and for our VR, so I'm right clicking on this, and I can also change its color to pink or something more visible. And I'm going to add 6 again, but also 0.1, and that's just going to offset it a little bit. It's just that they're not superimposed. I'm going to do the same for VQ. Perfect. Okay, so we can see our traces up here, so we can copy them in. And if we look at what happened there, so we can just click to drag to zoom in, and we'll just look what happened at that 700 millisecond mark. Okay, so we can see there's something strange going on. It's getting this bouncing happening. So if we look back, we can see our control signals here. They're going from the 0, 0 to 1, 1 state. So if we look back at our truth table, maybe you can ask yourself what happens with our SR latch as we go from the 0, 0 undefined state to a 1, 1 again. Okay, just as a recap, we went into LTSpice and we built a simple circuit, and then we went through and did a transient simulation on that. I hope that helped, and I'll see you in the next one. Bye.